So with this example, we've got a steel plate. We're applying a horizontal load or horizontal force to that. And we've got to figure out the maximum force before this plate starts to slip. So we're talking about a static friction problem. So looking at static friction. So what we are going to be using is, we know that the static friction is equal to the friction at slip, the frictional force at slip, or at impending motion when it's about to slip, divided by the normal force. And we, in our case, we're calculating that. What are we calculating? What the frictional force is going to be, maximum frictional force, which is just equal to your coefficient of friction times the normal force. They've given us the coefficient of friction, it's 0.3. But we need to find this normal force, and then we know, what else do we know? Well, we know that we've got an applied horizontal load. So when we calculate Fs opposing the motion, this maximum value of friction before slip occurs, the static friction, we know that that must be equal and opposite to P, so that'll give us P, the maximum force. So what we need to find out first is the normal force. We've only got a horizontal load, so all the normal force is coming from the weight of this block. So let's calculate that first. So we know that mass, we've been given the density, so we can calculate the mass first. So mass is equal to rho times volume. Rho is just the density, which is just 7.85 grams per centimetre cubed. So we just need to use centimetres for our volume. So that's 1 centimetre, 10 mil is 1 centimetre times 5 centimetres for the length. And then the question tells us that it's 40 millimetres wide, so 4 centimetres wide. So that is going to be equal to 7.85 times 20. Let's calculate that. 7.85 times 20 is equal to 157 grams. And so therefore the weight is equal to, excuse me, mass times acceleration due to gravity. We need to stick it in kilograms, so 0.157 kilograms times 9.81 meters per second squared. So 0.157 times 9.81, which is equal to 1.540 newtons. Kilograms in, newtons out for that equation, tons in, kilonewtons out for that equation. So now we've got our normal force. So let's just draw a free body diagram. It should always be what we do for these types of problems. And so we've got our little plate. We're going to draw that on its own. And we're applying a force P. We're going to have a weight W, which will, let's just see, I'll probably just draw it like so, just to keep it out of the way. So that's W is equal to 1.54 newtons. Then that means that the reaction force, we don't have any other vertical components. So our normal reaction is going to be 1.54 newtons. And we're going to find frictional force, maximum frictional force, Fs, and its magnitude is going to be equal to P. So then we're going to get, so we've now got the normal force. So this here is just equal to the normal force because we don't have any other vertical components. So therefore, Fs is equal to the coefficient of static friction times the normal force, which is 0.3, gave us that in the question up here. 0.3 times 1.54, oops, 0.54, which is equal to 0.462 newtons, 0.462 newtons. So therefore, max force that can be applied without slip is equal to 0.462 newtons. Might be a wee bit overly accurate that usually your coefficient of friction isn't accurate, but let's just stick with our usual rules of 3 significant figures in the answer. Done.